Right. So the topic is port channel. Port channel. Port channel. The other word for this, or other name for this, is ether channel. There is also another name for this called port aggregation. Port aggregation. See, you may hear any of this in interview or when people speak. All three are same. See, the link that we use is what we call it as Ethernet. So Ethernet links, you're going to channel them. Now, where is this Ethernet wire connects? It connects to port. So channeling Ethernet link is also channeling ports of those ether channels. So you can call it as port channel, ether channel. So channeling is nothing but aggregation. So you can call this as port channel or aggregation or ether channel. All three are same. மூன்றும் ஒன்றுதான். So let's learn what it is. Let's see what it is. When we speak about spanning tree, we understood that spanning tree prevents loop by blocking redundant links. For example, if I'll have switches like this, let's say it is connected like this, and there are many switches, it's going like that, okay? It's going like that. Now, if there is a block here, all the traffic that comes to this switch as well as to this switch will take the same route. Why? Because there is a block. Because there is a block. Due to this block, we are unable to use many of our resource. See, because there's a block, no traffic goes this way. As a result, you lost this bandwidth, you lost this device, you lost these devices, all the device, up, all are unused. Only when a link goes down, this gets unblocked, only then you will be able to use this path. In short, what I want to say is, even though spanning tree prevents loop, which is good, but there is a cost that you pay for it. There is no optimal utilization of resource. We lose a lot of our resource. We cannot use many of our resource. So spanning tree prevents loop, but there is a loss because of the block. Now, in that scenario which I just explained, you may not provide a solution in the CCNA level, but when you go to higher levels, like CCIE, we learn SD-WAN, VXLAN EVPN. And when you get into data center, you have fabric path, ECI, and much more, which can avoid STP. No STP, and there won't be loop as well. No loop, so no STP. So those are all different technologies that you will be learning later. But in a normal enterprises, they may not have the big devices to have those big features. So they sacrifice some resource to prevent loop. STP blocks the port and you sacrifice those port and those devices to avoid loop. Yeah. So we need to find some solution. There is a solution if you have two switch like this. I have two switch connected back to back with redundant links. We got redundant links. Whenever we have redundant links, there is a loop. That's what we learned. But we are learning something called port channeling. Port channeling. When we bundle this group of links, those ports, when you bundle, you call this bundle as ether channel, port aggregation, anyone. What happens really is these four links are going to appear as one link, port channel. If I say one, and it will be called as one, PO1 interface. Actually, they are not one. They are four interface, F0/1, F0/2, F0/3, F0/4. Actually, they are four interface. When they are separate four interfaces, to prevent loop, we know that there will be some blocks and only one link will be active. But when we aggregate them as one logical link, there's no chance for loop. You see, if you have you should not draw like this. And when I have only one link, will there be a loop? No way. There is no chance of loop because there is only one loop, only one link. Actually, when you configure port channel, it becomes one link like this. Physically, four link, logically, one link. பார்ப்பதற்கு நான்கு, ஆனால் செயல்முறையிலோ அது ஒன்று. தோற்றத்திற்கு நான்கு, ஆனால் ஒன்று. it will be just like one link with more bandwidth. We all know fast Ethernet is 100 meg. Now when you aggregate, it becomes 400 meg. See the advantage. If you don't do port channeling, you will have only 100 meg because there will be block in the other links to prevent loop. But when you aggregate, 4 appears as 1 and all 4 are available for you. All 4 are available for you. No blocking. Now, what if one of this link in the bundle goes down? No problem. All the traffic which was going in this link, now it will be shared to this link. And when this link comes back, again it will be put back to the same link. So you are able to utilize all the resource without any wastage or loss. Aggregation of links is what called as port channel. Advantage, you have high availability. High availability means what? Always available. If this link goes down, will you lose connectivity between down computers and the up computers? No. If this link goes down, will you lose connectivity? No. If this also goes down, will you lose connectivity? No. The port channel will never go down until you lose all of the links. Only when all the link goes down, this port channel will go down. Even if one is there, port channel will be up. All right, so you always have a guaranteed path. That's what called as high availability. Not only that, you got more bandwidth. Earlier you were having only 100 meg, even though you got 400 meg 4 wires, you were allowed to use only one because of STP's blocking. But now you got 400 meg. Yeah. Next. Redundancy is there. What is redundancy? If one is going down, no problem. The traffic can be put on the other link where the other traffics are going. Load sharing is there. When you have more traffic, you need not to excuse yourself on that one port. You can just share the load across multiple links. Load sharing is there. So you got the complete bandwidth. You got the complete bandwidth. Even if one link goes down, only the bandwidth will get reduced to 300 if one goes down. But the only the bandwidth goes down, but the port channel still remains. The communication between down to top and top to down continues. Whenever we lose a link, only bandwidth get little bit reduced, not the entire communication stops. That's a very good advantage. But you see, when we had that spanning tree protocol, when the primary link goes down, it takes some time for the convergence, for the other link to come up. And during that period, some packets get lost. But here you see there is no packet loss. And when you come to the professional level courses, you will see in spanning tree itself we have various uh, flavors like rapid spanning tree, multiple VLAN spanning tree. What is the difference? They are all making that spanning tree a little better, but nothing can make better like this. Portchannel makes much better than all those spanning tree flavors. You don't lose any bandwidth to prevent loop. You avoid loop by not by blocking, instead by aggregating all those links that are connected back to where back. So Portchannel is the best. Instead of trying this spanning tree, that spanning tree, Portchannel is better. If you have an option to enable Portchannel, you can do so. See, there is no drawback here. There is only advantage. You see, you got all the bandwidths, all the links, no wastage of bandwidth. Even if one of the link goes down, still no problem. There is no time taken for the convergence. What is convergence? What is convergence? What is convergence? Convergence is adapting to the change. Adapting to the change. நல்ல சாம்பார் சாதம் நெய் மணக்க சாப்பிடலாம்னு நினைச்சிட்டு வந்தா ரசம் சாதம் தான் இருக்குன்னா உடனே we adapt to change. It's okay, I'm hungry, give me the ரசம் சாதம் only, I'll manage. That is what called as convergence. Adapting to the change. See, when there is 4 link, 400 meg. When there is only 3 link, it's okay. I'll manage with this 300 meg. Same traffic will go using 300 meg. Only the bandwidth get reduced, not the communication breaks. No communication breaks. Okay, now let us go to the other side. Now, this Portchannel, you can simply enable on this place and on this place. You can simply enable Portchannel on these 4 ports. That is what I mean on this place. You can enable the Portchannel on this 4 port, and you can enable on this 4 port. When you enable them, the Portchannel comes up. As soon as you enable, the Portchannel comes up. We call this mode as on mode. On mode means you just turn on the Portchannel feature. You just turn on the Portchannel feature. That is on mode. There is also 2 other mode, which is before bringing the Portchannel up, before bringing this 4 link as one virtual link, the 4 ஒயரையும் ஒரு ஒயரா virtual லிங்கா மாற்றுவதற்கு முன்பாக 2 பக்கமும் சரிபார்த்து 2 பக்கமும் சரியாக கன்ஃபிகரேஷன்லாம் பண்ணியிருக்குதான்றத வெரிஃபை பண்ணி அதன் பின்னர் இந்த மாதிரி ஒரு வெர்ச்சுவல் லிங்கா மாற்றுவதற்கு ஒரு protocol பயன்படுத்துனீங்கன்னா அது on mode ஆகாது. Protocol. LACP ன்னு ஒரு protocol. We got a protocol called LACP and we got a protocol called PAGP. If you will use these protocol, any one of this protocol, to verify whether all our configurations are up to the mark before bringing up the port channel. We call it as dynamic port channel. This is not dynamic port channel. On mode is not dynamic port channel. You go to the interface and manually you turn it on. See, when you manually turn it on, what happens? They simply come up and say, port channel, port channel. What if you configured here correctly but not here? So this side will think you got the port channel correct on the other side. It will think and it will send the traffic. But the problem is accidentally you left this port. Let me repeat. On mode is not a recommended mode. Why, When the switch 1 brings the port channel up, it will not cross check with switch 2. It won't go and check with switch 2 whether the other end of the 4 wire is properly configured. It will simply declare, okay, port channel up. No more 4 link, it is one aggregated link. But what if, in this side you accidentally left this link. You did not include that in the bundle. You have not included this F01 in the bundle. You forgot. You bundled only this. Whereas here you bundled these 4. Switch 1 has got no clue that the other side is not properly configured. So switch 1 will try to send the packet as if it sends to a bundle, but here it is not really a bundle. So there will be a mixed behavior in the communication. You will see something abnormal in communication. Yeah. You don't have a protocol to verify whether the other side is ready or not. But when you use dynamic port channel, what is dynamic port channel? We have a protocol to cross check, like protocol like LACP, link aggregation control protocol. When you use this LACP protocol, that protocol will go and verify whether this link has got the other side properly configured, whether this link, it'll check all the links. Actually, it won't check like that. The LACP hello packets that comes, that gives a confirmation that other side is configured. Likewise, the hello packet that goes to the other side gives the confirmation that these ports are properly configured on the other side. So with that guarantee, the switch will say, okay, I'm bringing the port channel up. This will also, after verifying, it will say, I'm bringing the. That is good. So you can use IEEE 802.2AD LACP standard. This is what LACP means. IEEE standard. So it's not 2AD, it is 3AD. Is it so important? Not that important, but when someone speaks in a simple Tamil or English language, people don't admire. When you put some bravo, merci beaucoup, this fellow is educated, he speaks French. But he don't know that this fellow was begging in the streets of France. That's why he knows a little bit French. Indians. So likewise, If you speak some triple E 802.380, then this guy knows networking. Wow. Actually, he don't know anything other than this number. So it's not very important, but it is good to know to say, even these things. It's a document number, where this is mentioned. It's a document number. It's like Vandu Murugan talking about law. உங்களுக்கு தெரியாத சட்டங்கள் இல்லை, Your Honor. That type of people will use this IEEE language and all to quote the document where LACP is mentioned. Who wants the document? Do you know LACP? Do you know what it does? Do you know how it functions? Do you know how to configure? That matters. Okay, so this is one thing. There is another protocol I told you called PAGP, Port Aggregation Protocol. This is Cisco standard, so you don't have a document to refer. You don't have any number to call IEEE and all. This is Cisco standard. So in your environment, if you have one side Cisco device, the other side also Cisco device, you have two options. You can enable LACP or PAGP. If you will have one side Cisco and the other side non-Cisco, non-Cisco, they don't have PAGP. They don't have PAGP. So you should enable what? LACP only. Or if you have both non-Cisco, then you need to enable what? LACP only. Yeah. So LACP is industry standard. It's not a protocol defined by Cisco. It is an industry standard protocol, ISO certified kind of thing. Anyway, you got an option. And what is the difference? What are the other difference? One is LACP IEEE 802.3AD visa and PAGP is Cisco. What is the other difference? LACP has got two modes. One is active, the other one is passive. PAGP also got two modes. Instead of active, we call it as desirable. And instead of passive, we call it as auto. Now, what does that mean, active? You see, when I configure this side for this bundle active and this side bundle passive, which one will initiate the conversation to form port channel? எந்த பக்கம் ஆக்டிவ் இருக்குதோ அந்த பக்கத்துல இருந்து இந்த ரெண்டு இன்டர்ஃபேஸ் வழியாக அடுத்த சுவிட்ச் கிட்ட போயிட்டு போர்ட் சேனலுக்கு நீங்க தயாரா அப்படின்னு போய் கேட்கும். அதற்கு சுவிட்ச் 2 தயாரான நிலையில இருக்கும் பட்சத்தில், நான் அதுக்காக தான் வெயிட் பண்ணிட்டு இருந்தேன், நீங்க எப்போ கேட்பீங்கன்னு தான் வெயிட் பண்ணிட்டு இருந்தேன். That is what called as passive. So passive will never initiate the conversation. Passive will respond to the conversation. It is the active side which will go and initiate the dialogue, conversation to form ether channel. So one side active, one side passive, or both the side active is also good. Both the side means both will try to talk and both will try to bring the ether channel up. So here no one is waiting for the other one to start. அவன் பேசட்டும் அப்படின்னு இல்லாம ரெண்டு பேருமே என்ன காசா பணமா வாய் திறந்து ரெண்டு வார்த்தை பேசிடலாம். நல்லது தானே பேசுறோம், நல்லது தான் வரும், கெட்டது தான் பேசக்கூடாது அப்படின்னு நல்ல ஒரு புத்தியோட அப்படி ரெண்டு பேரும் ஒன்னா வந்து பேச வராங்க பாருங்க. தட் இஸ் வெரி மோர், தட் இஸ் மோர் more human than one waiting for the other to come and talk. That's more selfish. அவன் பேசட்டுமே, நான் போய் பேசலாமா? That's more selfish. As if, this fellow is going to live for 200 years. நாளைக்கு இருப்போமானே தெரியாது. இவருக்கு கௌரவம் வேற. இறங்கி போய் பேச மாட்டார். பேசி சமாதானம் நான் நைட்டோட நைட் கடவுள்கிட்ட போயிட்டா கூட நாளைக்கு அவன் என்ன நல்லவன் நினைப்பான். நல்ல வேலை சமாதானம் ஆயிட்டோம் அந்த திருப்தியோட போறதை விட்டுட்டு இவனா 200 வருஷம் வாழ்ற மாதிரி கௌரவம் எல்லாம் தலையில குப்பையெல்லாம் வச்சுட்டு இருப்பாங்க நம்ம நாட்டுல. So both the side active is good. One side active, one side passive is also good in here. So equivalent of active in Cisco is what? Desirable. Equivalent of passive in Cisco is what called as auto. So if you are going to use the word desirable, the switch will understand you are enabling what? Cisco's PAGP. Can I configure one side desirable, one side passive? No. Why no? Because it's two different protocols. They don't understand each other. So if you enable active on one side, you enable LACP. So on the other side also you should enable what? LACP. So either you put P or passive or active. Or one side if you say desirable, you are enabling PAGP. So other side you should enable auto or desirable. Auto or desirable. You see? Let us go and configure and see this. I'm going to take two switches. And I'm going to connect 4 wires. How many wires I can put in a bundle? You can put up to 8 wire in a bundle. 8 wire. So if each wire is 100 meg, you got 800 meg in the middle. But if you don't have port channel, how many megabits of bandwidth? Only 100 meg. Understand this very well. If you have 8 links in this bundle, all 8 links together will give you 800 meg. Each link is 100 meg. 800 meg with port channel. But without port channel, how many meg you will have? Even if you have 8 link, you see, even though you have 8 link, only one is green. Let me open and show you. Only one is forwarding, others are blocking. Show spanning tree, see? except one, all others are blocking, which means you got only 100 meg. 100 meg. Listen, 100 meg. What is the cost? STP cost 19. If I aggregate this four link, what will be the bandwidth? 400 meg. Will the cost go down or up? Will it go up or go down? Please tell me. After bundling, I'll get 400 meg. Will the STP cost go up or down? Will it be reduced or it will be incremented? Cost. Bandwidth அதிகமான cost குறையுமா கூடுமா? Very good. So after we bundle, I want to see this one and verify. I want to show you that the cost will go less than 19. That I want to show you. Now let us do this bundling. Here I want to name the switch as switch underscore 2. And I will say interface. See, in order to configure in all these four link, I'll say interface range F0/1-4, which means I'm going inside all four links. And I'm going to say all these four link as axis or all these four link as trunk. Remember, all these four links should be of same type, means all should be same axis or all should be trunk. இதில் ரெண்டு லிங்க் ட்ரங்காக வச்சுக்கலாமா, ரெண்டு லிங்க் ஆக்சிஸாக வச்சுக்கலாம், அந்த கதெல்லாம் வேணாம். 4 லிங்க்கும் ஆக்சிஸாக இருக்கலாம், இல்லை 4 லிங்க்கும் ட்ரங்காக இருக்கலாம். கலந்தெல்லாம் கிடையாது. It needs to be same, all 4 links. There is no mix match. And also the duplex. All links can be half duplex or all links can be full duplex. It's not some links are full duplex, some links are half. What is half duplex and full duplex, by the way? Let me show you. See, duplex, half, full, auto. The default is auto. Leave it auto. So what I'm coming to say is all should be either full or all should be half. Or what is half and full? Half and full எங்க தமிழ்நாட்டில் ரொம்ப ஃபேமஸுங்க. அந்த மாதிரி இருந்த ஃபேமஸாக இருந்திருந்தால் இந்த விஷயம் தெரிஞ்சிருக்கும். நெட்ஒர்க்கில் இது கொஞ்சம் ஃபேமஸ் இல்லை தான், சொல்லி கொடுத்தாதான் தெரியும். வாட் இஸ் ஹாஃப் டியூப்ளெக்ஸ்? Early days, there were many walkie-talkies. Today, cell phone is with everyone, so no walkie-talkies. In olden day, most of the traffic police used to have walkie-talkies. Not only police, not only the traffic police, even the civil police and forest officers used to have walkie-talkies. In militaries, too many walkie-talkies. What is the difference between walkie-talkie and a phone? The general difference is this. In phone, I can speak at the same time, you can speak, both can speak at the same time. நான் பேசிட்டே இருக்கலாம், நீங்களும் பேசிட்டே இருக்கலாம். இப்படி ரெண்டு பேரும் பேசிட்டு இருந்தால் ரெண்டு பேருக்கும் புரியாது. ஒருத்தர் பேச ஒருத்தர் கேட்க தான் முழுசாக கன்வே ஆகும், அது வேற விஷயம். What I'm trying to say is, in normal cell phones, if both talks at the same time, it works. It is possible. That is called full duplex. Our cell phones, our telephones, they're all full duplex. Even this conference meeting that we are having now is a full duplex. What is half duplex? Half duplex is, hello sir, mic one speaking, over. And then that fellow will say, mic one, sorry, yes, I'm hearing you, over. So at a point of time, only one can talk. ஒரு பட்டன் இருக்கும், அதை அழுத்தி இவர் பேசுவார். அப்போ அவர் அந்த பட்டனை ரிலீஸ் பண்ணிட்டு கேட்பார். அப்புறம் இவர் பட்டனை விட்டுருவார் ஓவர்னு சொல்லிட்டு. அப்புறம் அந்த ஆள் அங்கே பட்டனை அழுத்தி பேசுறது இவருக்கு கேட்கும். This is how the walkie-talkies work. This is what called as half duplex. Now, even in networking, some cables will do half duplex, meaning it cannot send and receive at the same time. It cannot send and receive at the same time. They are called half duplex. If a wire can send and receive at the same time, transmit and receive at the same time, then we call it as full duplex. You see, let me show you. Interface show interface F0/1. If you see here, it has received some packet input and it has received some packet. It is also ready to send some packet. So both the transmit and receive can happen at the same time. And if you see somewhere, it is written full duplex. Full duplex mean what? This port can send and receive at the same time. So what I'm coming to say is all links should be same type. It should be full link or half link, half duplex or full duplex. You cannot have few links as full duplex and few as half duplex. Now, going back to the story, interface range F0/1 channel group. So, okay, let me first say switch port mode trunk. I want all the port to be trunk. Okay, so I made it as trunk, and then now what I say is this is the command I said switch port mode trunk, and it has become trunk. Now all are similar trunking. Next is I'm going to do channel group command. Give any number. Whatever the number that you put here, that will become the number for the virtual interface PO. PO, I drawn a PO, PO. PO is the name of the bundle. This number one, is decided here. If you put one here, that will be one. If you put two here, then it will be two there. You can put any number. Now mode. You see, on mode is not recommended. You are turning it on manually. If you are using LACP, it is active and passive. If you are using PAGP, it is desirable and auto. Now I would like to enable LACP, so I'm saying active on this side. Active. So you don't need to say I want to enable LACP. You simply say active or passive. Now go to the other side. Go to the other switch. Switch 1. Interface range F0/1-4. Switch port mode trunk. Channel group 1 mode. That side I said active. This side can I say auto? That side I said active. Can I say auto this side? What, sir? That side, if I say active, I'm enabling LACP. If you say auto, what you are enabling? PAGP. One side LACP, one side PAGP. Is it correct? No. No. Other side can be active or passive. Passive is also LACP. So I'll say passive. All right. Now we got the port channel. Let me show you. Show IP interface brief. You see, you got an additional new interface called port channel 1. And now I should, why it is down? Why it is down? Let me see why it is down. Show ether channel summary. This is the verification command. It says standalone. Okay, it has come up now. It has just come up. Now let us verify. It is up. That's why, the protocol will take some time to negotiate. Now going to the switch and I'll check show ether channel summary. It says all these 4 links are in bundle. And protocol that is used to negotiate is LACP. It's a layer 2 ether channel. S means what, S means layer 2, you see. Capital U means what, in use. It is in use. Layer 2 ether channel is in use. Now, if you go to the other side, Show ether channel summary. Here also you can see, here also you see all are in the bundle. This capital P, in the bracket, the capital P means it is a member of port channel. It's a member of Portchannel. So now, when I type show spanning tree earlier, I had 4 links, but now I have only 1 link. And the cost was 19, but now it is only 7. Why? Because it is shared link, it is bundle, it has got more bandwidth. Earlier it was only 100 meg, cost was 19. Now you got 400 meg and cost is 7. Now let's say show interface port channel. Show interface, okay, ether channel. So the ether channel interface, you got F01 and then F02 and then F03 and F01, all are in this bundle, in one bundle. Yeah. So there are 4 ports as a member.